Hey, it is Thursday, 4:20 p.m. Eastern. That means it's time for office hours, AROYA's weekly session for cultivators to hear from the experts and talk to each other about what they're seeing with their grows. My name is Kaisha. I'll be co-moderating today with my good friend, Mandy. How you doing, Mandy?
Hey, Kaisha. If anyone has a question today, you guys can go ahead and type it in our chat at any time. If it's chosen, we'll go ahead and have you unmute yourself and ask away, or we can ask for you. We did have some great topics to go ahead and cover this week, so I'm going to go ahead and pass it back to Kaisha.
Excellent. Thank you, Mandy. Yeah, so you folks, feel free to type any questions you have in the chat. Just to let you know, if you're a first-time question asker, you're going to get some swag. And then everybody who's on today will have a chance to win a limited edition AROYA t-shirt. So be sure to drop your email address in the chat so that you can enter to win. All right, Seth and Jason, how you guys doing?
Good. How are you, Kaisha?
Good to see you. So our first question is just kind of like a general overview. We actually had conversations together, me and you, Jason, earlier this week about sensor density. So why don't we start there? Can you guys give a little bit of an overview about sensor density, what it is, and what cultivators need to know about how and where to place their sensors?
Sure. So when we're talking about sensor density, basically we're talking about how many plants of a population are you monitoring with a substrate sensor. And in most of the hydroponic applications that we're working in, obviously plants either have their own individual substrate or they'll share it between 2 and 3 plants, maybe on a rock wool slab. And so when we think about crop uniformity, really we want to know how closely are all of the plants performing root zone wise. And that can give us an idea on how easy it's going to be to steer the plants. If we've got plants that are operating much differently, then we're definitely going to have to take that into consideration when we make steering decisions. One of the nice things about cannabis is when we're working with cloned plants, their genetic makeup is very, very similar, much more than we would be in seeded plants. And so that does help. But obviously, the things that come into play is, how consistent we're taking our cuttings, how consistent is our irrigation systems, basically the ways that we're treating those. Is it keeping those plants in the similar enough growth pattern to each other in order to apply crop steering? So, obviously, one of the things that we hear quite a bit when we're talking with clients, especially when they're migrating from some of the previous systems that were offered for root zone monitoring, is that they were so expensive that maybe they only had one sensor in a whole room. And I've had many clients, I've heard it way more times than would have expected, is that the plant with the sensor was growing great and that the rest of the room had lackluster performance. So that's in one case where the steering based on the data was working very well for the plant that they had data from. They just didn't have enough data in order to capture a great picture of the entire crop. So really kind of just a default that we go by is that you should have one substrate sensor per 100 square foot of canopy. And obviously that's not necessarily digging into the details about differences in genetics. So are you running a monocrop? You're running multiple strains in a room? Do you have vast environmental differences? Is there some variance? If you're running in like a 150 foot or 200 foot wind or tunnel, like a high tunnel or something, you're definitely going to see big environmental differences from front to back. In some of those cases, you might need a little bit higher sensor density in order to definitely start to attribute how uniform those plants are. And I'll dig into it a little bit more here in just a minute, but I kind of wanted to get Seth.
Yeah, it's really important because when you're looking at, sensor density in general, we've got, let's say, one sensor per 80 plants, right? If I've got that, I can assume that 40 are going to be a little bit above and 39 are going to be a little bit below that plant. The smaller number that I have to make those assumptions about, the more accurate I can be on actually implementing some of these changes in crop steering. And even though, most of us might think we have a really uniform environment, let's say right back to what Jason said, if you've got microclimates to deal with at all, you've got to capture that and decide how am I going to treat that part of the room differently. And then, extend that into today's market. And there's very few growers out there that I've met that are able to monocrop with their marketing strategy. Maybe if their facility's been built out in a way that they're really churning product and they have small rooms, but most growers are forced to grow, 2, 3, 4, 5, 6 strains every time in a room. And there's really no way, with those big of differences that you're going to be able to crop steer without having visibility on each individual strain. So, even when we look at some of our customers that are like boutique growers, 1,000 square feet, if they're growing 8 strains in there, they'll have 8 sensors, even though they're, way over the sensor density they might need if they're even, let's say, 600 feet. But it allows them to actually, have greater success and maximize what they're getting out of that small area. And, like Jason said, years ago, these sensors were so expensive that, going into a commercial greenhouse, you might see 1 or 2 in a 5 or 10,000 square foot bay. And that's just, when we talk about a greenhouse, if it's 150 feet long, we've got air coming in one end and out the other. Of course, we're going to have a gradient and everything from humidity, temperature, how fast the air is moving in there, where it's blowing. We need the highest density that we can reasonably afford to maximize production there. And we do have several clients that, when they first start, just because of the price, not that ours are particularly expensive, but hey, everyone's trying to keep their costs down, that price per pound of production. But after using it for let's say 6 months or a year, a lot of times they'll double their sensor density because they're looking at it and going, man, I've got really good control of these 2 out of my 4 benches in that room. So I'll double it, and usually they see an appreciable increase in their yields and have the ability now to run, let's say, split rooms much, much easier.
And just kind of anecdotally, so, I was running in a 125-40 greenhouses back when I was cultivating, and I'd usually be operating on worst case, 8 to 10 degree temperature increase front to back. And so, unfortunately, we didn't have as many sensors in there as I would have liked, especially for environmental factors front to back. So some of that information was captured with just snapshots, manual readings. So going in there with a handheld hygrometer, thermometer, and taking point readings, point in time, point in space, and documenting that. And unfortunately, you can't get nearly as much detail as you can because, especially in greenhouses, there's a ton of dynamics going on. We're looking at vents, we're looking at ridge vents, we're looking at fans, pad pumps, all that type of stuff, floor fans. And so those can all change, especially if you're running an automated system in a very interesting environment like we have. You can be 40 degrees in the morning and, upwards of 70 or 80 by 2 or 3 in the afternoon during some of our seasons. And so it's hard to capture, all right, well, how can I operate this equipment differently to minimize that difference? And one of the most important things that I came to realize was trying to optimize crop's location in the greenhouses. We were forced to run multiple strains in the greenhouses. And I realized, well, if we have a crop record on how this specific strain functions, does it prefer a little bit higher temperature? Is it one that we need that color and those nighttime differentials? Well, if it is higher temperature, let's push it to the back where the exhaust fans are at. If it's one that we really need those colors at, we'll put it towards the front. And when that pad opens up in the morning, it's definitely going to get a little bit extra cooler than I want the entirety of the crop. And so when we think about sensor density, it is definitely important to get the environmental component of that as well, and then pair it with the root zone, because what we want to see is, not only the response from the plants, but what caused that response in the growth and the transpiration rate of those plants.
Yeah, absolutely. I mean, I've been working with people pretty regularly this summer that are really struggling with heat in their buildings, for instance. So we're going okay, what's causing these plants to stretch out? Okay, go move your climate sensor over towards that wall that's near the outside. Well, it's 90 degrees over there. So, even though you might not have a huge room and it doesn't seem like you'd have some microclimates, most facilities end up having them. I mean, it's very difficult to design a room in a 3-dimensional shape the way we do and have airflow through it just perfectly. And then you add on to that most growers aren't in a building that was specifically designed to grow plants. So everyone's got, a little bit of compromise somewhere in their design that they had to have just to fit into that building and usually achieve the parameters that they need to, especially if it's an older grow that's been upgraded over time. If you don't have the sensor density or just the data from all those microclimates, you might be able to crop steer, but you're going to be chasing your tail a lot more trying to solve problems that you might be able to solve just by shoving a climate station in a corner for a few days and going, oh yeah, It gets really cold over there. That's why everything's struggling in that corner. That's why it's real purple. Without that increased visibility, you just can't implement the changes that you need to.
Yeah, anyone that's interested in kind of digging into the statistical or math side of this, I did a YouTube video. It kind of documents, I think it's called Crop Uniformity and Sensor Density. It's up in our YouTube channel there. Look it up. I talked a little bit about population curves and analyzing the standard deviation over your crop. Really, basically the things that are most important about using a high sensor density. If you don't have enough sensors in there, it might be hard to know if all of your crop responded well to a change in steering parameters. And so basically showing you, hey, here's the numbers that you need to be looking at, and this is what happens when we shift, when we're monocropping, and maybe when we make a shift for multi-crop that makes some plants grow better and maybe some plants grow worse. So just ways to mitigate that. And obviously our harvest groups are the best way that you can track genetic-based performance and match it up with data points from every 3 minutes of a grow cycle.
Yeah, and when you up that sensor density too, it gives you eyes on things that would have previously taken, just a lot of effort to gather. So if we can double or triple our sensor density in a room, now we can see what, our uniformity across the crop in terms of water content at field capacity, let's say. Well, I know for me, that's going to influence, will I buy that brand of cocoa again if I'm running cocoa? Does it indicate some other problem with the way I'm hydrating my media? I can start to see things where if I didn't have the sensor density, I'd have to go out and manually check that constantly to try to get that variation at the end of my P1s. And that's not necessarily practical. Plus, you only have a limited amount of time right after that irrigation to go gather that data before it's not really going to be relevant because the plants are drying back. We won't know exactly what field capacity is on all those. So having those eyes just really opens up a whole world of possibilities and knowing what's going on inside your root zone. And then identifying things. Like I said, if you got media quality problems and you haven't been checking what your field capacity is really regularly across all of your cubes when you hydrate them, you might not know that that's an issue. We might be assuming that, hey, everything's running in a pretty good range, and we didn't actually realize that one of the boxes we got is running 20% lower than everything else. It's just really dense material. So we just want to be able to see that and catch it. And that's also, kind of the key to really dialing in that crop uniformity.
Yeah, thanks, Mandy, for posting up that link there. It's in the in-call messages chat in this Google call. So, check it out. I think it's a pretty short video. It's going to be well worth your time. One of the things that surprised me most very early on when we were doing installation, Terros 12 installations in the hydroponic medias, I think it was maybe 2 weeks in, right after one of my first installs, I notified a client that, hey, your water content's looking low, and it was a clogged dripper. Would we have caught that if there was less sensors? It's just like buying a lottery ticket. You don't know. If you buy a lot more lottery tickets, you're more likely to win. So, having those sensors in there and seeing things like a clogged emitter or an emitter that got pulled out of the substrate, it's really surprising how often we see that with clients that are doing a good job as far as sensor density, but may have other challenges that those sensors can help them address in their rooms.
Oh yeah, even eyes on. Let's say you've got an irrigation system that has a lot of manual valves that you turn to clean it. Someone leaves a solenoid off and walks away and goes home. Now at least someone's going to get an alert, and we won't catch it 2 days later when that table's wilting. Little things like that are, it's not always easy or cost effective right away to engineer, say, your irrigation system with a bunch of fail safes. And even if you do, even fail safes fail. We're talking about mechanical automated systems. Unless someone's standing there, you should trust it. You can trust it, but things break, especially, if we're talking about, say, dosatrons, for instance. It's a great product. I love them, but they are consumable. They have wearable parts inside. There's replacement parts available. If you weren't regularly checking what's coming out of your emitters, for instance, you might not be aware that you've got it set to feed at a 3.0, but I run into this a lot. A year later, now it's only putting in a 1.5, or you reorganize your irrigation system. You don't have as much flow. It's not mixing right. So, you can chase your tail for a while on something like that and go, man, I have it set at 3.0. And then finally, when you go do the table test, you're like, okay, if I just would have had that ES2, I would have seen like this decline over time. Or, hey, right when we changed up this irrigation configuration, our EC just dropped out in the line. Like the injectors aren't working right. But we find that a lot of people, when they don't have that visibility, won't notice that for maybe, you know, like a whole run. They're going, why the heck are my plants? You know, they've gotten to trust their equipment, which is good, but they just didn't necessarily know, say, that it required that high level of maintenance.
Yeah, you know, one of the things that is interesting as well is just some data redundancy, like you're talking about. When it comes down to these systems, is like even the most reliable systems sometimes get touched by an uneducated human being. One time I was looking at our light readings in the greenhouse, and I thought, man, we got a problem. Is my blackout closing up when I didn't expect it to? Why is my light reading so low? And it ended up that the sensor was laid on its side. And so the light sensor was at a perfect 90-degree angle. It was functioning great. Obviously, if I would have had AROYA, I would have had more light readings in the room, and I would have been saying, okay, well, I need to just go check out that sensor instead of get worried about the actual function of the crop. So having some multiple data points. So when you do have some issue with one sensor, that you can go in there and say, all right, well, 15 or 14 of my 15 sensors are saying that there's no issues. Sensor number 15's got some erratic data or something I don't expect. Let's go pinpoint that section and see, hey, is this a real world incident where the plant's having a problem or the environment's having an issue, or there's a chance that the sensor's just given some issues. So even with the most reliable sensors, something like the AROYA system, every once in a while people get involved and or a very unlikely failure. So I think that's one thing that, especially in control systems, that I always made sure I had programmed, was things like a backup temperature or a backup humidity, and actually did random checks on the consistency between my backup and my regular. So I had some lines of codes in there just basically saying, hey, if we see temperatures that are different between these two sensors of more than 2 or 3 degrees, then send me an alert that basically says, hey, you need to check on your sensors. Is it one getting out of calibration? What's going on that would exist, that differential we don't expect?
Yeah, and I mean, you should always just look at redundancy as insurance as well. There's a reason you get a fire safety and security system, and that's not necessarily tied into your fertigation system. Part of that is that, no matter what's happening inside the facility, you want your cameras to stay on and you want your security system to work. And the best way to do that is to have a dedicated system that's not going to get interrupted if something else fails in the building.
We did have a client where their fertigation system did act as a fire suppressant when the fertigation line melted and it put out the fire after the lines all broke. Kind of just an interesting, sad and or funny story about the challenges of growing indoor.
Did he advertise to Dab with that one? Give that for him. Like, hey.
I don't know if they did, but
their automatic pressure equalizing pumps are perfect.
I was pretty amazed to see like 165 degrees on our climate station, I think, before it finally gave up the ghost due to smoke and flames.
Yeah.
Awesome. Thank you guys for that. It's like such a great topic to cover and so much important stuff that you guys got to share with us. We have a ton of questions that have come in through the chat since then. Forrest, yours was first. Do you want to go ahead and take yourself off mute and ask Seth and Jason directly? Or I can ask for you if signals are bad.
Sure. I was just wondering if you can talk more about the first and last 2 hours of when the lights are on, and if plants receive the same signal from feeds during these times.
So, photosynthesis takes a little bit of time to actually get going. In cannabis plants specifically, I've seen information as far as in between, 30 and 45 minutes for when the plants finally wake up and the photosynthetic activity is up to daytime normals. And so, we like to see those plants start getting hungry before we start feeding them. And that'll just make sure that you have a very active plant by the time that you begin to irrigate, and it'll make that irrigation give it a nice growth signal, if you will.
Yeah, I mean, basically, if we put on water too early in the morning, the plant's not going to uptake it as fast. So it's kind of more of an efficiency issue where when we're crop steering, we want an immediate response from the plant. So we want to put water on and have it be uptaken. We don't want it to sit and stagnate in the pot. And, waiting 2 hours before lights on means that the plant is respirating, it's transpiring, everything's happening, rolling good, it's ready to take up those water and nutrients. And then in the evening, basically pulling back 2 hours before lights off, that makes sure that our overnight dryback is kicked in and we're actually putting a little bit of generative stress on that. If we just kept watering it all night and kept that water content super high, we wouldn't get good oxygen infiltration into the roots. We have that classic overwatered plant.
Yeah, and another reason I just don't like to irrigate too close to lights off is a humidity spike that most growers are trying to combat, via kicking on their dehumes a little bit earlier before lights off. It's definitely probably a little bit more brutal when you're running HPSs just because they are burning off so much humidity during the day. But if we're irrigating that late, we're just introducing a bunch of unwanted problems water-wise, both in the root zone and in the environment.
Yep, and that's a good point. We want to make sure that plant's pulling water out of the pot, not it's just evaporating. We don't want to have that extra water in the room overnight.
Forrest, did we answer your question? Anything to add?
Yeah, I was just wondering if there was like a time when I can add a supplemental feed to where it won't affect it the way it usually does. That's all.
No, not really. Those buffer zones are really what preserve that overnight dryback.
And that's kind of, the general rule of thumb is if we absolutely have to have supplementals, then maybe we need a little bit different size substrate or we want to be growing a little bit different sized plant in that substrate.
Awesome. Thank you.
Mm-hmm.
Forrest, thank you so much for your question. The chat's lively right now. We got a question from our good friend Bilbo. Bilbo, you want to unmute yourself or would you like me to ask?
I can ask it.
Go for it.
Hey, thanks for your time, guys.
Mm-hmm.
Is it feasible to crop steer in 1,332 mil or 0.35 US gallon truncated pyramid pots in my high CEC substrate? That's the question. And to give some context, I feel the answer is yes. The rest of my team doesn't seem to feel the exact same. We do have the capacity to irrigate as we see fit. I want to keep the labor costs down by avoiding a transplant, as these are the same size pots that they were steered through veg. These plants have been topped at least twice because they were growing so aggressively under 300 ppfd. The plant density planned for the flower room is 14 plants. Well, that's basically how many we have spread out over the lights we have in the room. And yeah, I'd love to get, whether it supports my hypothesis or not, I'd love to get some insight.
Yeah, I mean, it's certainly possible, to be honest. It's as long as your plants aren't too big for that media size, you can absolutely crop steer with it. Even with the high CEC substrate, your biggest challenge is just going to be, knowing that you're going to be stacking EC a lot quicker inside that media and then making sure that you're maintaining enough runoff to flush it out regularly.
Right. And then with that said, the fact that, we're basically not going to run out of irrigation fluid anymore, and it doesn't require someone to be there to top it up. I feel like even watching the graphs over the past run with that high CEC substrate, whether it was through veg or generative steering at different morphological stages of the plant life, it never got out of hand. I don't know if that's because of the surplus of cocoa that's in there or the amount of perlite that's in there. Like it's fairly well draining. I would like to see a bit more aggressive drybacks. So that's kind of actually why I'm leaning towards even a smaller size substrate effectively. Our current run in that same room has probably twice the size of a pot, and the plants had to be over vegged because of some clerical errors on my part. So I guess I'm going completely opposite of what I've already experienced in this same site. And, I just don't want to be the only person saying it's possible. Do you know what I mean?
Yeah. Well, one thing is that I always like to talk with people about is that everything's being crop steered, whether it's being crop steered intentionally whether it's being crop steered well, those are different stories, right? The plant is reacting to however it's getting irrigated in the environment it's in. It just happens that are we steering the plants or are they steering us? And, something like this where you've got a high planting density, almost one plant per square foot. I'm going to assume that you guys are running, a little bit smaller plants and definitely trying to turn those around as fast as possible.
Yeah, I mean, in that media size, I'd probably be looking at like a 2-week veg max. And honestly, I'd probably try to just go high density, possibly even higher than you're at, and not top them. As quick a turnaround as possible.
Yeah, and I mean, in a perfect world, that's what it was set up for.
Okay, cool.
Just due to timing of recommissioning the facility, it didn't work out exactly as planned, and that's why they were topped in veg, because they're already past day. I believe today's day 26. And I've been doing really generative steering in veg to slow their growth as much as possible and not just let them go running wild. It hasn't necessarily worked exactly as I planned. So yeah, I would definitely, that's the only reason they were topped.
Oh yeah. Well, you'll remember it next time. I guarantee it. For reference though, we do have people that are able to crop steer quite successfully in just 4-inch Rockwell cubes and a flood and drain table at a super high density. And that was their goal in the greenhouse, was low cost of production, touch the plant as minimal as possible. Turns out you've got to keep them around 2 to 3 feet tall max finished if you're going to be, running in a tiny media. That's really the main limitation when you're crop steering, is making sure not main, but one of the biggest ones for determining whether you can effectively steer with irrigation is making sure your media is appropriately sized for your plant.
Right.
Yeah, and I mean that's pretty cool that you mentioned that, because I remember the first install that we sold with the flood and drain, and I told the guy, I'm not really sure how that water content's going to behave in those blocks. We've never really studied Rockwell flood and drain with the Terrace 12s. And after a few days, I had a huge grin on my face, and the results were incredible. Obviously, a lot different behavior than we're used to seeing in a drip system, but it's very effective.
Oh yeah, and in a setup like that, you're able to steer generatively very easy, just because of the fact you're not doing these tiny drops on you. You have to wait so long for it to wick water up.
We are in drip. So we do have that going for us.
Yeah, and that's good. That makes it a lot easier. I just wanted to give you for reference, like there are a lot of different styles of growing that people are able to crop steer effectively in, as long as they nail down those parameters that they need to be watching to, actually implement, generative specifically, implement that 2-hour irrigation window and 22-hour dryback.
Cool. Thanks.
Yeah, it's always good to see you. Thank you for your question. We got another one that came in the chat too. Justin, do you want to take yourself off mute and ask Seth and Jason? Or I can definitely ask for you. So Justin says, hey, everyone, love your content. Thank you, guys. I've been wondering what ECs should be sustained during midday in the generative stage. What should I see as an EC before my first irrigation? And when is the best time to stack? So a couple of questions there.
Yeah. So, I mean, one thing to remember is that when we're talking about EC throughout the day, we're always going to be talking about a range. As your water content's going down, especially in generative, that EC is going to go up. So early in the morning, you might have anywhere from like a 7 to a 12 EC right before you water. And then at peak capacity, we might be back down by like that 4 to 7 range. But again, we never want to sustain a constant EC during the day. That's not how plants are adapted.
Yeah, I mean, especially when we're trying to give them a generative signal, that rise in EC is creating an osmotic differential that is signaling that plant to change some of its growth behavior. And always my disclaimer on the numbers that we pass out, it's going to be a little bit dependent on what nutrient brands you're using. It's going to be a little bit dependent on the strains that you're running, and it's going to be dependent on the goals that you're trying to hit. How much crop steering are we applying to this? Yeah, and how much can a specific plant take? That's something. The ranges that you're planning for strain dependent values are just pretty wild, actually. And like Jason said, it really varies with nutrient brand. If you've got a fertilizer mix that has an obvious deficiency in it for that strain,
that's going to limit growth in ways that might not be quite obvious. So with one brand, we may need to be, you know, getting it up to that 7+ range. Another brand, we might not. We might, with the same plant, we might not have the same deficiencies just because of the composition of that fertilizer.
Seth and Jason, Justin also posted a clarification, spoke to this being a 6x6 rock wool cubes in a flood and drain system. So adding that element, if
cool,
in case helpful.
And then I guess, when is the best time to stack? Generative steering. That's when you want to do it. And you do that by minimizing runoff. Although in flood and drain, it might not stack up super high for you. That's one place I don't have the most experience trying to stack, to be honest.
Yeah, and a lot of times when we think about generative stacking, we're looking at what's the low value from yesterday and what's the low value from today in that substrate for the EC. And with flood and drain, it's going to be a little bit tricky unless you do some adjustments to your feed EC levels. Simply because you don't have a lot of control on how much runoff you have.
Mm-hmm. And then one thing to remember too is you're with flood and drain, you're recycling your nutrient solutions, so the composition of that solution changes over time. And I mean, of course, I'm sure you have a dumping schedule. You're only running the same solution so long, but yeah, I mean, a good way to think about EC in relation to the plant is in deep water culture, we can't really stack. And in flood and drain, you can to an extent, but that might be a challenge, is really dialing in that feed EC, and then, from there, making sure you've got a good program, knowing when you've got to dump your solution, when you got to refresh, are you going to do a half dump, a full dump? It's certainly a little bit more dynamic than drain to waste.
Justin, you'll have to let us know if that answered your question, or if you have any follow-up questions. We did get another one. He says, thank you, guys. We did get another question from Forrest. Forrest, did you want to go ahead and ask the guys?
Sure. I was just interested, or would like to hear if there's a correlation between introducing oxygen into the block and nitrogen uptake.
Dissolved oxygen in the fertigation supply, dissolved oxygen is a good thing. It's going to help keep your roots healthy. I don't specifically know if there's a relationship to nitrogen uptake as a specific nutrient in there. But anytime that you can get your dissolved oxygen in optimal levels, it's going to keep your roots healthy, and it's going to keep them white and keep them from rotting out.
Yeah, and a good thing to remember too is, like, every time we put an irrigation event on drip, like a drip irrigation specifically, as that water moves through the media, it's pulling air in behind it. It's also pushing air out of the space below. So we are pulling oxygen in, and that's part of the signal the plant actually does get to uptake water and nutrients, is that introduction of oxygen into the block. It's raining out. But that's always happening every time we irrigate. So in terms of nitrogen uptake, like if we're looking at, plants that have a tendency to uptake nitrate preferentially late in flower, it's going to happen every time we irrigate. So how do we address that? Well, for some strains, figure out a way to back off on the nitrogen. That's why a lot of traditional mixes, you had a early, mid, and late flower recipe, and progressively you're pulling back that nitrogen throughout.
All right, awesome. Thanks.
Yeah.
Thank you for your question, Forrest. Okay. We did get one question in on Instagram, and actually I think it fits with what we're talking about. Cap Ain't Cappin asks, what's your best method on bringing down your EC level substrate during veg steering?
Increase runoff.
Yeah, add a second runoff event after your initial P1. So your first P2, have that go right back up to field capacity. And, I would probably start only doubling my runoff, not tripling it or anything, and then making sure you've got an intuitive feel for how much, let's say 20% runoff is going to drop your EC the next day in your media.
Well, that was straightforward. Thank you. Okay. And then I think, really like that was all we have right now. Our attendees, please do drop your questions in the chat if you have anything for the remainder of our time. But, we started this hour talking about some common issues that you guys see clients run into as far as sensor density. Are there other common troubleshooting areas maybe that we can talk about that you guys do see, Seth and Jason, when you're visiting clients, just reminders for like AROYA is going to work better for you if you kind of remember to set things up a particular way or some guidelines or some benchmarks that they can be paying attention to?
I think Seth and I could talk on this topic for the rest of the afternoon.
Yeah.
So maybe we just want to select a few, the most common and obvious ones that we get started with.
So, where I focus on a lot with people, especially, when they're haven't been able to afford the sensor density they want. So everyone you talk to, if you can, if they had their perfect world, they'd have a sensor on like every other plant. I mean, I know I would, but that's not realistic, right? So we have to look at the statistical significance of where we place those sensors and how well that represents the room. For instance, if I walk in and see your climate station hanging right next to your DHU in that hot air blast, we got to move that so we have an actual representation of what the room's like. We got to get it down in the canopy, not directly under a light. We want it to be the most representative. So that's like one of the first things. And that extends to pretty much, it's not just the atmospheric sensor, it's the Taros. Anything you're sensing, you want it to be as representative as you can of the rest of the crop, the rest of the room.
Yeah, and that's where it's actually nice, if you have the time, energy, and resources to go in and do a bunch of spot measurements before installing some of your stuff, and just think about the variance across the room. Or do we have wide aisles where the aisle plants might be getting a lot more light and very likely more transpiration? They're seeing more airflow. A little bit different environment. Or do we have a really, really dense, thick canopy where we're going to see the interior plants having a much different environment and less light than those aisle plants. So those are, just a couple of things that you want to keep in mind. And obviously, I think we talk about manual readings, spot measurements quite a bit. We talking about them today quite a bit. And I think when you work with traditional growers, they go in there and they feel the room, and that's really, really important. To go in and feel the room. And what happens is if you take a measurement, then you can communicate that with other people in the facility. You can communicate that with your stakeholders who you're trying to get some money for improvements in the facility. And so really applying an engineering and scientific approach to the feel in the room is the most important aspect of approaching it with a successful business mindset.
Yeah, and I'm glad you brought that up. A lot of growers out there that are coming kind of into the technology age of growing. Like say you're just now starting with salts and you've been in soilless mixes for years doing organics. Some of the tendency is to not want to trust the technology because you've had a green thumb forever and your instinct's been good. Well, it's not a instinct versus quantifying thing. Use these tools to quantify what your instincts are telling you. So yeah, if you have a cold corner of the room, if you're like, man, I swear I see condensation on there some mornings, go stick a climate sensor in there for a few days and see if that corner really is cold. Start mapping your microclimates out and then figure out where you don't want to put that sensor. That way, you're not going to be falsely led to making a control change that you don't want to. Like just AC. Like I said, if that's sitting in front of the DHU, you might have your AC blasting like crazy in that room. It might be like 68 in there, but you think it's 84.
Oh, that's great that you mentioned that. So it reminds me of, I think it was probably month 3 of my cultivation career when just like weeks after I started using some meter group products, and I had the sensor stick, and it was my mobile climate sensor, and it was just a stick that I'd zip tied to different uprights, and so that I could take a time series spot measurement, if you will. And so I'd log, one area for 2 or 3 days, and then I'd move it to a different area and log that for 2 or 3 days, and really kind of compare, hey, these spot measurements, when I look at them over time, how do they compare? And obviously, one of the challenges is, none of the days are the same day outside when we're running in greenhouses, but it is nice to, shift those in a time lap and say, all right, well, when we're running a specific piece of equipment, we see this corner have an increase in relative humidity, or we see, this corner has a lot higher light levels in the morning than this corner. So being able to compare some dynamics, across more spots is why having more sensors is going to give you a lot more information about your facility.
Oh, absolutely. And it at least allows you to figure out like, okay, what are the limitations that I have inside this growing facility? What can we control? What can't we control? And how can we actually solve some of these problems? If you don't quantify that, like I've definitely seen people do it, especially in the greenhouse world. Like, hey, let's just go buy a bunch of dehumidifiers and put them in there. How big? Like, what do you mean, dude? This is a big room. How much dehu capacity do we need? And then also, what are some of our other solutions if we look at like in the greenhouse specifically, other options out there, like spending more money on a nicer vent system? Looking at, okay, what can we do without altering this? Or, hey, if we've been having horrible mold rates, like we're losing, we figure 20% of our crop to it, maybe we should pack that room a little less and, open it up, go with a little less dense canopy and go, okay, we need to make business decisions based on 80% of what we thought we could grow. And that's just the reality of making sure that we're still here growing next year and not at a different job.
Yeah, one of those things as well is don't be afraid to be a little bit creative. Obviously the traditional horticulture industries are a great example and standard to work off of, in greenhouses and growing basics. But cannabis is an extraordinarily aggressively growing plant, and so it's going to require usually a little bit more inputs or a lot more inputs than traditional plants. And sometimes like we're going to exceed the capacity of a grow room or a greenhouse that was engineered for another crop simply because of how much production that we're hitting. And like one example is when we help people start crop steering, a lot of times we'll see that they run out of dehumidification capacity. We've just increased the amount of biomass in the room so much that transpiration rates are overpowering what the room is designed for. In those kind of cases, then you definitely need to, think about re-engineering them or reducing plant density, that type of stuff. And every once in a while, you just run into a situation where, it's a one-off thing. Back in those greenhouses, we had some days that were up in, 107 degrees outside. And I actually have one of my favorite growers down in California runs into this every once in a while there in Sacramento, where he just runs out of cooling capacity in his greenhouses. And, my solution was I went to the grocery store and I bought bags of ice and I threw them in the pad pump. And that was amazing. It did an incredible job. Just, we already had well water coming out at, pretty cold, like 62 degrees, and just dropping that evaporative water temperature even more. We were able to get through a few really hot days. So, don't be afraid to be creative and use your mind and open up to the fact that there's not a lot of documentation on how to grow cannabis at scale right now.
Absolutely. When you're talking about the traditional horticulture industry too, when we're looking at calculating like our heat needs, humidity needs, we look at everything in a range on a delta. Well, they had small deltas, and cannabis requires big deltas is the biggest thing I've learned, trying to troubleshoot these HVAC systems over the years. And like Jason said, there's not that there's not good information out there, but we're young enough in the industry where a lot of people are finding out those values themselves still. And either they're not in the business of, building new grow facilities, and this is just something they've figured out through trial and error, or they are in the business and, that's not information that's just being published all willy-nilly. If you're a mechanical engineer who's put a lot of time into developing an HVAC system, it's partially proprietary at that point, I would say, and that's part of why we're not seeing, super easy resources out there for some of this stuff. And
I love this conversation. I'm sorry to interrupt you guys, but this is so great because it's just true. It's truly an example of being creative and resource sharing for a group that has always had to be super resourceful. I wanted to make sure that we address some comments that came on the chat. Forrest, you posted something about stagnant AC. I wasn't sure if you wanted to chime in on this conversation or if it was related to something else.
It's just kind of related. I was wondering if it was. Sometimes I see stagnant EC at night, and I'm wondering if that's an indication that there's something wrong environmentally.
So you're talking about your line flattening out in terms of EC?
Yeah, just will flatten out. Other rows in the room will go up, but then like some specific rows will more than one. Typically, we're kind of looking at a heavy feeder at that point then. You know, nighttime's a time when plants move around a lot of things. And also what that means is that plant's pulling enough salt out of that media that the ratio of water to salt is not, or salt to water, is not rising exponentially as it comes down in water content. So salt's leaving the block, but so is the water. Flat line. All right, awesome. Yeah, and is that a bad thing? You know, maybe not. Depending on, you know, looking at growing other crops, I would probably constantly be riding that line and say, okay, how much is just enough? Because my profit margin is pretty, like, let's say I'm growing blueberries. I'm actually going to try to not stack that EC up too much, depending on how much stress I want to put on and like what kind of fruit quality I'm looking for. But a big part of it's economic too. If that line is climbing and I'm pushing lots of runoff and being wasteful, I'm not making as much money. But now when we're talking about cannabis, different goals. Again, though, that flat line, if you don't see a deficient looking plant, it's not something I would spend a lot of time worrying about, especially when you're running that strain in a room with a bunch of other strains. You can try to stack it a little bit, maybe raise your feed EC, but if it's one bench and you got 9 other benches in the room, all you can try to do is, you know, reduce runoff and stack it. But you want to watch your pH. If you're doing that and your pH starts dropping through the floor, okay, well, now we got to go back to more runoff, which is going to drop our EC out, and just decide like, okay, how much do I chase this around? And then realize that we're adapting this plant to a range of EC for its life. And the more time we spend going up and down out of that range irregularly, the more we're just going to stall the plant and suppress growth. I just had one quick follow-up question. Can higher EC potentially cause cultivars to stretch during Gen 1? Not typically. Higher EC makes it a little bit more difficult for the plant to uptake water and nutrients. So usually we'd see the opposite. If you're running a real low EC with high nitrogen content during, you know, your first 3 weeks, that's going to really promote that stretch. All right, awesome. Thank you. No worries.
Thanks, Forrest. Yeah, thanks for the question. We got a couple more questions to get through before the show wraps up. Bilbo Baggins, did you want to go ahead and ask Seth and Jason your question, or I can ask for you?
Okay, I'll ask.
Go for it.
Navigating to the chat so that I can recall what I... One sec. Okay. What are your thoughts regarding calcium carbonate and or potassium sulfate used in late stage ripening? And that's the question that I had about 11 minutes ago. Then there was some conversation about correlation, and then I wanted to get the dialogue going about talking about the knee-jerk reaction that humans have to deduce that correlation is causation. Maybe you guys have some ideas as to how to retrain the brain other than going through our graphs. And I guess it's probably time series data over time that built into the comment that I said pro versus bro. You know, that again, that old hat way. There was a comment around I had a green thumb. I didn't believe the data. But it starts off by asking calcium carbonate, potassium sulfate.
Sounds like you do you mix your own fertilizer? And that's just what you prefer to use as your calcium source and your potassium source?
I have in the past, but we're talking over a decade ago. Now it's currently, you know, popular brands, but I'm trying to dispel what I knew.
Okay.
In a different peer group than what was working over a decade ago. So I'm asking about components that are in common products without mentioning the common products.
Okay. Yeah, I don't see a particular problem with using calcium carbonate or potassium sulfate in late flower. I mean, it's a common ingredient. you see around. The biggest thing I see between different brands, obviously there's ratios of everything, but a lot of times it's just manufacturing quality. How clean is it? How well does it dissolve? Does there seem to be a lot of filler that's left in the tank in my lines after I run it?
Right.
Otherwise, I mean, at this point, the fertilizer game has gotten so much better than, let's say, 10, 15 years ago. It's just ridiculous. Right.
It was clear problems then.
Exactly.
Sorry, They weren't even clear. They were murky.
Yeah, that's a good way to put it.
Okay, so the knee-jerk reaction. I mean, you guys are in a tech-forward organization, science-based, data-based. I'm talking about the parent co. How do you guys fight that or combat that as people of science to not have that knee-jerk reaction? Oh, this must be the reason.
I mean, I just go back to the scientific process. Let's apply an A/B test and limit as many known variables as possible in that A/B test. And if we have as many variables identified as possible and we're analyzing them and we know that there's control with our EC, control with water content, control with amount of lighting, maybe we just want to try a slightly different VPD. Well, let's not change temperature and humidity. Let's just make a change to say humidity for that strain and run an A/B where you've got how you did it and then your thoughts on what a change in that variable might do. And then obviously just document the hell out of it. Take lots of pictures during the entire thing. And then, every once in a while, you catch something that you didn't expect. And, if you have surveillance cameras in your grows, do some time-lapse footage of how those plants are growing and the morphology. Maybe you're trying to determine how long to stack for a specific strain. Go back, make a time series, see how those plants were responding to the different changes, the A versus the B. And, I think so many of us, it's like we learn something and we get really, really excited to apply it. And, it makes me jealous of facilities that have 50 rooms or something, because it's way easier for them to make fast improvements or changes because they can do a one variable change on a room. They're all right. Well, we're planting a room every day or 3 rooms a day. Well, let's do one room as our A, our control variable, and let's do room B with that minor modification and run them right next to each other. A lot of facilities don't have that luxury, where it's like, all right, well, we gotta do an A/B test, but I have a 5,000 square foot room. Maybe I'm running only 2 of those rooms. Well, it's a huge investment to do a small modification just for hypothetical proof, if you will.
Yeah.
Oh yeah, absolutely. And I just want to add to that one thing I'll get people to do pretty frequently when they question like the sensors and stuff is I'm like, hey, let's do some exercises. Go grab some plants, grab your Atmos, have someone just hang that Atmos up. You walk by it and then go look at the computer and tell me what temp did you think it was and what did that say? And it might be close, but just kind of get used to the idea that we're doing everything analytically, and also a part of, agricultural science is not, especially in the way we're doing it, graphing like this. The value is not always in, let's say, the system's ability to predict what's going to happen tomorrow. It's in your ability to utilize it and look back, not just at yesterday, but at that whole last run.
I 100% agree with that. I find that, mentoring or leading a charge of individuals who do have a ton of bro experience and bringing them into pro, it's always reiterating, hey, go back and look at your historical graphs. That histogram is there to help you see, what you were seeing based on your crop registrations day in and day out, and what's changed in the morphology, what's good, what's bad. Do you remember that day? Let's look at our notes. I 100% agree. I think this ties in nicely to the, again, pro versus bro, and something that I found that really helped me start that bridge, or at least build it from a quantitative side to people who may be more qualitative, is I found some Greek words, kairos and chronos. So you have kairos being the how did it feel? the qualitative, and chronos being the binary, the zeros and ones, what happened. And I find that when you ask someone, okay, what's your kairos on leaf temperature or pest pressure or this, it puts it into, they already know in our organization, they already know that I'm looking for a number, but we can possibly tie that number to how you felt about it. Because it really is just as much as, you guys are talking about implementation. We're having to implement new ways of thinking to an entire industry that precedes this recent development of tech. It's challenging, I guess. That's what I'm wanting to wrap it into.
Oh, yeah. And I mean, another thing I tell people is like, hey, we're right now in the midst of an evolution where this is going from largely a boutique industry to a commercial one. And you've got to decide where you want to survive and how you're going to do it. The days of having your basement make you money are kind of over. So are you going in with a boutique strategy? We're going for the top quality bud we can, yields are important kind of, or are we looking at like, all right, how are we turning as much green as possible out of this space? And it's, for some of the older growers that are like, have that passion for the plant, that's wonderful. That's great. A lot of people have great passion for their tomatoes too, but they aren't farmers because they like to eat their tomatoes at home. And when you put the idea of like, okay, to do this at scale, you're not going to give the tomatoes love anymore. If that is not appealing, you might not be like a good fit for a bigger grow. Someone like that might want to look at starting their own, like, micro grow and getting a small license or trying to go into the medical industry.
Thanks for the color.
Bilbo, you always ask such great questions. Thank you so much for that. I do want to make sure we have Diane is on with us. He had 2 questions. Diane, I want to make sure we get to those before the end of the show. Diane, can you unmute yourself, or would you like me to ask these questions for you? I'm thinking I'm going to go ahead and ask for him. All right, here's the first one. And it actually ties into what we were just talking about with Bilbo. How can I explain to my boss that VPD in night, it's important with simple words, what's going on with the plant at night?
Yeah, it is important. I don't personally feel that it's quite as important as your daytime VPD. There's a little bit more leniency there since the plant isn't trying to optimize its growth rate at night. We do see very significantly reduced transpiration rates at night. Obviously, you do want to keep it within safe ranges. If we've got VPD up at 2 at night, the plant's probably not going to be very happy about it. And if we've got a, VPD at say 0.5 when we're in flower at night, it's probably a little bit lower than ideal. So,
we want to stay in range. And if you're like talking to, explain to your boss why it's important, do you have mold? If after week 6 or so, your VPD slips below 1.1 or 1.0 at night, there's a good chance your crop's going to start molding, especially if that's sustained throughout the last few weeks. So VPD at night is important in terms of, avoiding mold. So we can't go too low. And then also there's the efficiency part of it. So as Jason's saying, if you're way high VPD at night, that's a little tough on the plant. If we're running like a 2.5 at night, that's also not going to be very water efficient. So we're finding that balance between, how hard is the air pulling water up through the plant? And then also, like when we get to ripening, it's got to pull enough water up. We got to avoid mold, but we also want to be able to put that generative stress on till the next day. So they're all little pieces of the puzzle. And like VPD, for instance, especially your daytime VPD, if you can't get that up, you're not going to see your drybacks. Like if you're new to crop steering and you're going, why can't I can only get a 10% dryback ever. And I'm in a 1.5 gallon pot. Like, okay, how humid is it in there? What is your VPD? Are you actually in a range where that plant wants to grow? And if you're not, the plant's not going to grow.
Fantastic. Thank you, guys. And then let's get to Diane's next question, which will be our last. Should I stop the nitrogen totally in the end of flower, or will my plant still need some nitrogen at the end?
It depends what the end means, specifically in time frame of the plants. I see a number of nutrient brands out there that, their flower formulas are very low in nitrogen. So.
Yeah, you don't need to totally drop it out. Plants still need a little bit. The thing to remember is that different plants are, especially different strains, are very susceptible to preferential nitrate uptake. So when we're trying to ripen that plant, the important thing to remember is that nitrogen, once it gets in the plant, somewhat acts like oxygen. It causes cells to elongate and the plant to grow vegetatively. Well, we don't want that. So if there's a high nitrogen concentration and that plant is susceptible to uptaking it, that's when we might see, you know, some of those white pistils down to week 6, 7, 8, a little bit of that re-veg growth. But in general, most plants will only take up what they need and let the rest go right by them. So it's highly strain dependent. And I've noticed that doing that, you know, basically, if you've ever were of the school where you did a 2-week flush at the end, you were doing that anyways. And when your plants were showing colors, aka dying, that was because they had no nitrogen or anything else to sustain themselves with. So I don't recommend fully dropping it out. Just back it off slowly. And then, yeah, just remember certain different strains are going to behave differently. That's why, you know, everything we talk about here is a set of tools. And it's more about learning how to use them and when than saying there is a hard rule on this or that. Because there's always an exception for, I mean, other than VPD and mold, I think that's about it. And even that, man, I know Jason's seen a few moldy greenhouses in his day, and man, you'll have one bench of a plant that's just like, let's throw it all away. Like, and then the bench next to it, nothing. You got a completely resistant plant. So even there, like.
It was the green crack.
Oh, yeah. Yeah, that one couldn't go in that corner.
Nope.
Or at the front, or in the middle.
Awesome. Yeah, green crack, always problematic. Diane, thank you so much for that question. Thank you to all of you for your questions. My goodness, what a great show. Mandy, thank you for co-moderating with me. We got anything else? We good to go?
I think we're all set. Yeah. Thank you guys for another great show.
Yeah. Seth and Jason, you killed it as usual. Thank you guys for your wisdom. And thank you to everybody who joined us for this week's edition of AROYA Office Hours Live. If you have any questions about AROYA, book a demo. Let's see how AROYA can help your commercial cultivation. And then going forward, let us know if there's any topics you'd like for us to cover in a future office hours session. Send us a message over the chat. Shoot us an email at support.aroya@metergroup.com or send us an Instagram DM. We want to hear from you. We record every session. We'll email everybody in attendance a link to the video from today's discussion. It'll also live on the AROYA YouTube channel. Be sure to like, share, and subscribe while you're there and spread the word. Thank you, everybody. See you next time.